The United States produces more economic output than any other nation, but the physical energy to keep that engine running ignores the political border. In 2024, $124 billion of raw energy flowed south from Canada into the United States. This movement does not rely on cargo ships or shipping containers crossing oceans. It's a hardwired physical architecture of steel pipes and high-voltage transmission lines permanently linking two landmasses. Three distinct streams flow continuously through this infrastructure: crude oil, natural gas, and electricity. To understand American economic dominance, you must look past political maps and international trade deficits and read the physical engineering schematics. The United States currently extracts more crude oil than any country on Earth. Yet it simultaneously remains the single largest buyer of Canadian oil. Comparing foreign suppliers, 4.1 million barrels flow daily from Canada, eclipsing all others combined. Transforming to a scatter plot by viscosity and sulfur reveals why. Canadian crude is uniquely heavy and sour, isolating it in this quadrant. Structural engineering mandates this import. Standard geopolitical market forces do not control this massive cross-border movement. Geology and chemistry mandate it. The bulk of this flow consists of Western Canadian Select. Western Canadian Select, or WCS, is a specific heavy, sour crude oil blend extracted from the bitumen-rich oil sands of Alberta. Once extracted, this dense liquid travels through dedicated pipelines directly to refining hubs located in the U.S. Midwest and along the Gulf Coast. American energy companies have sunk billions of dollars into these specific facilities. They are built with specialized thermal and catalytic cracking units designed exclusively to process heavy crude into usable fuels like diesel and gasoline. Meanwhile, the current drilling boom in places like Texas and New Mexico produces West Texas Intermediate. West Texas Intermediate, or WTI, is a light, low-sulfur crude oil that serves as a major global pricing benchmark. These legacy heavy crude refineries cannot efficiently process this lighter Permian oil in large quantities without massive, costly reconfigurations. This mismatch creates a highly profitable loop. Because Canadian heavy crude is landlocked and difficult to transport globally, American refiners buy it at a steep discount to produce domestic fuel. This allows the U.S. to take its own premium light crude and export it at full market price to Europe and Asia. This physical refinery symbiosis mathematically lowers gasoline prices for American consumers, while simultaneously funding the nation's position as a dominant global oil exporter. Operating in tandem with the oil pipeline network is a secondary, largely invisible flow of natural gas. An average of 8.5 billion cubic feet of natural gas crosses the border every day, accounting for nearly all natural gas imported by the U.S. This map displays the topographical layout of North America's fractal, branching natural gas pipelines. The architecture is so deeply interconnected that gas flowing from northern extraction sites behaves exactly like domestic U.S. distribution, ignoring the political border entirely. This gas flow travels directly into residential heating grids during winter months and provides continuous baseload power for heavy manufacturing facilities across the northern states. If you sever this seamless northern integration, major American industrial sectors would face immediate baseload shortages and highly volatile energy prices. The third and final, as well as the most instantaneous layer of this entire continental machine, is the electrical grid. Exactly 86 bidirectional high-voltage power lines physically stitch the two nations' power grids together. Much of the electricity flowing through these lines is generated by Canadian hydroelectricity. Because operators can physically control the flow of water through dam turbines, hydro acts as a dispatchable macro battery. Unlike intermittent solar or wind power, it can be turned on or off instantly to meet exact grid demand. In 2024, 35.6 million megawatt-hours of electricity flowed south, providing enough continuous energy to power over 3.3 million American homes. Highly congested grid regions, like New York, New England, and Minnesota, relied directly on this imported power to prevent blackouts during peak summer demand or severe droughts. This vast hydroelectricity capacity acts as the ultimate grid shock absorber, protecting American infrastructure from localized failures without adding a single ton of carbon emissions. This composite map displays all three physical streams, oil, gas, and electricity, operating simultaneously. Three pillars make this mega machine possible: contiguous geography, entrenched legacy infrastructure, and long-term political stability. Mapping these energy nodes against major U.S. economic output zones reveals a direct correlation. Decoupling this system is a mathematical and engineering impossibility. Replacing these physical inputs would require trillions of dollars in redundant domestic capital expenditure and decades of new construction. This invisible, borderless foundation acts as a structural shield, insulating the North American economy from global energy shocks and the volatility of overseas supply chain disruptions. The title of the world's largest economy relies heavily on the illusion of lines drawn on a map. The reality is that American economic supremacy is entirely dependent on operating North America as a single, unbroken engineered organism.